Welcome to video PN-14, Dependent Probabilities with Marbles. This is taken from Lesson 5, Example 6. Here's the problem. An urn has 5 blue and 7 red marbles. You choose 2, one after the other, without replacement. Find the probability that both are blue. The second is blue, but not the first. The second is blue. And finally, that at least one is blue. Okay, I'll work through it. I'll give you exact simplified answers with the calculator. Probability that both are blue. The first is blue, followed by the second. All right, for the first to be blue, there's 5 successful outcomes out of a total of 12. So I've picked a blue marble, thrown it away. Now let's see what remains. For the second to be blue, there's 4 remaining 4 blue marbles and 11 remaining total. I'll crunch that out. That'll be my answer. Part B, the probability that the second is blue but not the first. Well, the first is not blue, it must be red. So probability of red followed by blue. For red, 7 out of 12. I took that red marble, threw it away. For the second marble to be blue, there's still 5 total blue, but only 11 total. I'll use my calculator to crunch that. Part C, the probability the second marble is blue, without regards to the first. Well, the first marble could be blue, or the first marble could be red. So when I see or, all I do is I add. So for part C, I'll just sum my 2 previous results. Part D, probability at least one is blue. I'll show you 2 ways of doing this. All right, at least one being blue, probability of blue, blue, or probability of blue, red, or probability of red, blue. So I've got those 3 cases. In either case, at least one is blue. But there's an easier way to do it. If I see probability of at least one being blue, that's going to be 1 minus the probability that none are blue. Again, if I get at least 1, that's 1 minus the probability of none. So I'm going to do it that way. All right, the probability of none being blue, well, that would be red, red. And for red, red, the first one being red, that would be 7 out of 12. Took that red marble, threw it away. Second marble being red, 6 remaining out of 11. And I'll crunch that with my calculator. Okay, so that's the conceptual setup. All I gotta do now is compute them. Hopefully that won't take too long. All right, for the first one, parentheses 5 divided by 12, and parentheses 4 divided by 11. I'll go math frat. I get 5 over 33. All right, second one. What I could also do is just multiply the numerators and divide it by the denominators. That might be quicker. Let me try that. Numerator, 7 times 5 divided by denominators, 12 times 11. I'll go math frat. 35 over 132. This one was just the sum. So since I've already got 35 over 132 on the screen, I'll just add it to 5 over 33. Again, I'll go math frac and get 5 over 12. And then finally, I'll clear my screen. 1 minus, I'll multiply the numerators, 7 times 6, divided by the denominators, 12 times 11. Then again, I'll go math frac. 15 over 22. And there you have it. How to use dependent probabilities to figure out problems with marbles.